Today I'm going to talk about how we can start designing the front and rear wheels for an F1 racing car following the 2022 technical regulations from F1 in schools and designing in Autodesk Inventor 2022. To start with, I have open here a brand new part file in metric units, so I will be designing in millimeters. And the reason for that is the technical regulations from F1 are listed in metric units. So we're just going to follow suit there. I'm going to start a new 2D sketch, and I'm going to start a sketch on my XY plane. Now, the way I'm going to be showing you how to design wheels is what I find to be the most efficient and practical way to design a wheel. It makes it very, very easy in the future when you have to come back and refine or change your design, which we know as you get further and further into designing and testing your F1 car, you're going to be coming back and making changes to a lot of your parts. So you want that to be easy to use. I'm going to start by just designing a 2-point rectangle. I'm going to line up the bottom of my rectangle by using my horizontal constraint to a bottom corner onto my origin point. That just lines up the bottom of my rectangle with my origin. And then we're going to throw a couple dimensions on. So I'm actually just going to throw these on and then change the numbers in a minute. I'll throw this one on. We'll start with that. Throw this one on and we'll go change this. So we need to know the width of our tire here. Now what I'm drawing is actually just the top profile, the top half profile of my wheel. Once I design this, I'm going to actually revolve this guy around this center axis here. So this is just the top half side profile of my wheel, if that makes sense. So let's take a look at our technical regulations here. What I've done is I've gone through those regulations and I've taken just snippets of the stuff that pertains directly to our wheels. So to start with, we can see T7.1 says that we have a maximum of 2 wheels allowed at the front and a maximum of 2 wheels allowed at the rear, and that's in total, including both sides. So we cannot double up our front or rear wheels. If we come down to T7.4, we can see we have some dimensions that we can use. T7.4 goes over the track contact width. Now what this means, this is the part of the wheel that is actually going to be touching the surface of the track. So it does not include, you can see here in the middle and the far right image, it does not include this little space between the dimension extension line here and the dotted line, because that part of the wheel doesn't touch the surface. It's lifted off the surface. So the track contact width is just the straight part that's touching the bottom of the surface here. We can see that we have 2 minimums, one for the front wheels and one for the rear wheels. So we're going to be looking at our front wheels right now, and our front wheels have an absolute minimum of 12.0 millimeters. And they are very sticky about this. 11.999999 will still lose you the points there or give you that penalty. So we want to be careful that it is exactly 12.0 or bigger because we don't see a maximum listed here. So I can change this dimension now by double clicking on it to 12. I'm going to be working with the absolute minimum, and I'm just going to quickly center my wheel here over the origin point. So now we need to know how big our wheel can be, what the diameter of our wheel can be. We can find that in T7.5 of our technical regulations, diameter, and we can see that it has an absolute minimum of 28.0 and an absolute maximum of 34.0. And notice one thing here, it does not list off different dimensions for the front and the rear wheels. So this, because it doesn't list off different dimensions, this is for both the front and back wheels. So again, I'm going to go with the minimum of 28.0. I'm going to do that by starting my general dimension button, clicking the bottom line of my rectangle, clicking the top line, and then before I place this guy, I'm going to right click and choose linear diameter. What this does is it gives us the overall diameter of this wheel, taking into account that this bottom line here is going to be the center of my wheel. So I'm going to place this and type in 28. And this is nice. It gives us a visual of how big this wheel is going to be, and I don't have to do math to figure out what half of this is, which is always nice. So before I can finish sketch and revolve this, we need to think about how our wheel is actually going to attach to our car. Is it going to have an axle running through the middle? Is it going to have a bearing first that the axle sits in? Is it going to have a suspension system? Is it going to just clip onto the car body? So we need to design a way for this to attach to our car. So for example, here in this image, we can see a few different axle options here, different sizes of carbon fiber, some steel axles, and 3 different sizes and types of bearings here, 1 flanged and 2 without the flange. So we have lots and lots of options. For right now, I'm just going to design my wheel for a 4mm carbon fiber axle. So I'm going to do that by creating a 2-point rectangle right here, and I'm going to say, okay, my axle is going to insert from this side into my wheel, and let's just dimension that. I'm going to dimension this so that my axle will insert 8mm into my wheel, and just like I did the linear diameter over here, I'm going to do the same thing for my axle. So I'm going to dimension from this bottom line to the top of my rectangle, right click, linear diameter, and I'm going to type that in as, let's go 4.5. And the reason I'm doing 4.5 is if I'm designing this for a 4.0 carbon fiber axle, I need a little bit of tolerance because we know that some 3D printers don't always print perfectly, and we need a little bit of space on both sides for that axle to actually fit in here. You might want to do a bigger tolerance if you're planning on using any sort of adhesive in here, because you are allowed to use any sort of adhesive that does not add volume to your design. So a super glue that dries without leaving a volume would be allowed. Okay, so I have a basic wheel here ready to go. I'm going to finish sketch, and I'm going to revolve this guy. So coming up to my 3D model tab, clicking on revolve, I'm going to only revolve this space here in green, because remember, we want to leave this little rectangle down here as a hole. So I'm going to just revolve this top shape here around the center of my wheel, and I'm going to go a full 360 degrees because we don't want this wheel to have a chunk taken out of it. Click OK. So here I have just a very, very basic wheel that meets our regulations. And let's quickly make sure I didn't miss anything here. So we did T7.5 and T7.7. Let's talk about this one for a minute. So the rolling surface. Your wheel diameter must be consistent across the track contact width. So what does that mean? Let's translate that a little bit. So what it means is the profile of your wheel that actually touches the track surface has to be constant or uniform, or basically it cannot have any sort of pattern or anything taken out of it. So like they say here in their example, you're not allowed to have tread-like features. It also means you can't have an angled wheel. So we couldn't cut our wheels at an angle. We can't have them in a diamond shape, because this bottom part here and all the way around that touches the surface must be exactly the same all the way around. Okay, so if we take a look here, now I'm just going to quickly, I have my material already set here to plastic, and I just want to come into my eye properties. So I'm going to right click on the name of my part, and I'm going to choose eye properties and come over to the physical tab. In here, if I click on update, because I have a material in here, you will get physical parameters about your part, and we can just take a look here at our volume. So our volume is about as big as it could possibly be. And the reason for that is we have a wheel here that we don't have any sort of profiles on the front, we don't have any sort of profiles on the back. It is basically one big disc that fills up those dimensions, and the only thing taken out of it is room for the axle. So this is a very large volume wheel. Now with our F1 cars, we're always trying to minimize weight on our cars because it's very, very difficult sometimes to meet that weight requirement. So one way we can minimize weight is in the wheels by doing some cutouts or some profiles on the front and back of our wheel here. So let's jump back into our sketch. I'm going to go into my sketch again by double clicking on it, and let's make some changes. One of the easiest ways is to just fillet or chamfer the edges of your wheel. So I'm going to click on my fillet button. I'm going to fillet 1.5 millimeters, and I'm going to do my top 2 corners right here. Now make sure you don't do the bottom ones, because remember, this is in the middle of our wheel. Close that. And now before I can click Finish Sketch, we have to change something here. Remember our track contact width we talked about. Remember that it doesn't include those filleted corners, because if we look here, the only part that's going to be touching the surface of the track is this line right here. These corners will not be touching. So I need to delete this 12 dimension and redimension just the length of this horizontal line that'll be touching the track. We can see right now it's at 9.0 millimeters, which is below the minimum, so we would lose our marks there. So we're going to change that to 12. Now the part that's actually touching our track surface will be 12 millimeters. Now you may want to change how far in your axle goes here as well, because our wheel has just gotten 3 millimeters wider with those two fillets. So we could come in here and we could make this 9.5 if we wanted to, or whatever you find works best for your car when you go ahead and test it. So if I finish sketch now, we can see the changes are updated automatically here. So we can see our car wheel has changed a little bit. And if we go into our eye properties, we can see our volume's gotten bigger. And the reason for that is we have added 3 millimeters on both sides of our wheel. So let's go ahead and keep making changes here. So I'm going to double click on my sketch. And I'm going to make some pretty drastic changes. So what I'm going to do is I'm actually going to start a line, and I'm going to just draw some profile shapes in here. Okay, so what I'm going to do here is I'm actually going to cut this rectangle you see right here. I'm going to cut that out of the wheel so that it is no longer included in the volume. And I'm going to cut this shape right here out of the front of the wheel as well. So I'm just going to quickly dimension this. Oops. Okay, so I've thrown some quick dimensions on here. The only things that I'm really critical about are the thickness of the shell, so the thickness of the plastic that will be holding onto the axle, the thickness at the front of the wheel here. I just want to make sure they will be strong enough. Again, if I was to manufacture this by 3D printing it and then testing it, I might find that I could cut this down to maybe 1.5 millimeters. Or I might find that my 1.5 right here isn't big enough. So some of that will just be taken care of through trial and error. So I'm going to finish sketch, and I'm just going to double click on my revolution here to change the profiles. So I'll just unselect everything. Okay, so now I'm going to revolve this shape right here and click OK. All right, so here we can see we're starting to get a much more advanced looking wheel in front of us, just with some quick changes there. So we have our chamfer, or our beveled edge here at the front, which removes this volume from the front. We have the same at the side here, or the back, where we've removed this cylinder here, just leaving just enough to hold on to the axle that we're putting in there. And now if I was to go into my eye properties and check my volume, we can see that we went from, I think we were at about 9,000 after we filleted those corners, and we're at about 4,000 now. And I think when we originally started with our square cornered block wheel, we were at about 7,000 and something. So we've cut this down quite a bit, and we could continue trimming this, maybe by doing smaller fillets, by doing a steeper angle here, by making these walls, these shell walls here, a little bit thinner. So you can continue to refine this, making sure though, of course, that your wheel is still strong enough to support your car up and down the track. So here we have our finished, this would meet our front wheel regulation requirements because we did the 12 millimeter width, which is for the front wheel. Keep in mind for your rear wheels, they have a minimum of 15. So you could use this exact same design for your rear wheels by coming into your sketch, modifying your track width here to 15. You know what, I'm going to do this. There we go. So we could change that to 15 if you want your axle to go in a little bit further. There we go. And we could use this for our rear wheel with some very quick changes in there as well. Okay. Now, if you're using bearings, so if we look at this image again, so we designed just for a plain axle there. If we're going to be using any sort of bearing, you have two options. You can either attach the bearing directly to the wheel, and then the axle will sit in the bearing which is in the wheel, or we could attach the bearing to the car body or the suspension system or the wheel support system which is on the car body, in which case you do not need to make allowances in your wheel for the bearing. So you're either designing it in the car body or in the wheel, basically. If we jump back into Inventor here, I have an example of a wheel designed for a bearing right here at the end. So we can see I've left, this was for a flanged bearing, so I have a little space right here for the flange, then the bearing sits right here, and then my axle would go right through that bearing and then sit into this hole right here. So I've actually just cut out a spot for my bearing here to sit directly in my wheel, and that bearing would get glued directly into the wheel so that it wouldn't just wiggle around. If we took a look at what that looks like in a profile, we can see right here is the space I made for my bearing. So this is where the flange sits from here to here, and then this is where the bearing itself sits. And I grabbed these measurements. These measurements are directly off of the bearings using a caliper, and then of course with a little bit of tolerance because the 3D printers do not always print perfectly. Sometimes we get a little bit of extra plastic in there, so we need some tolerance. And then the axle itself would go right from the end here directly into this hole. So this right here is just for the axle. So that's how you can get started designing front and rear wheels for your F1 in Schools race car. These designs are, again, the possibilities are endless when it comes to the profiles you choose, how thick you design your shells, whether you have your bearings in the wheels or not, whether you design without bearings, etc., etc. There's tons and tons of options, but this should get you guys started when you get into making your own designs.